In this video, we're going to look at spheres. There's three good definitions we want to think about with a sphere. The first is the actual definition of a sphere, which is all the points in a space. If you remember, the definition of a circle is all the points in a plane, but now we're talking about a space, so it's 3 dimensions, equidistant from a single point. That single point is referred to as the center of the sphere, just like it was the center of a circle. A hemisphere is half of a sphere. But when you think about cutting a sphere in half, it is a plane that goes through the center, and what's created, if we think about it, is just a circle. If this is our hemisphere, something like that, you can see that it just turns out to be a circle that you're looking at when you find a hemisphere. So it is half the surface area of the sphere plus the circle that is cut off. So you just think about the radius. And then a great circle is any circle that's created by slicing the sphere in half through the center. So whenever you create a hemisphere, we refer to that as a great circle. And great circles are very valuable because they're on the outside of a sphere, and it's along a great circle that the 2 points on a sphere must travel to be closest together. So great circles are very interesting and stuff you should learn more about. There's two formulas for surface area and volume of a sphere. They really aren't easy to prove, and so it's just a matter of memorizing them. For the surface area of a sphere, all it is 4 pi r squared. You may know of a baseball, and you maybe have seen a baseball that has been shred apart, and that when that happens, it looks something like this. You get 2 pieces like that are put together, and these 2 pieces put together to form the sphere that is a baseball. But if you look at it, they almost look like 2 circles. And so that's where the intuitive 4 pi r squared comes from. Even though it's not exactly an explanation for it, it is somewhat intuitive. The volume of a sphere is very not intuitive at all. It doesn't make really any sense in what we've learned about geometry. It's just 4/3 pi radius cubed. So surface area is 4 pi radius squared. Volume is 4/3 pi r cubed. So we're going to use these equations a couple times. So let's find the volume of a sphere with surface area of 100 pi. Well, the surface area formula is 4 pi r squared, and we want to set that equal to 100 pi. Surface area of any old sphere. Here's the surface area of our sphere. Set them equal. We should be able to solve for r. It's nice because there's only the one variable, r. Pi's cancel. Divide both sides by 4. You get r squared equals 25. So when you take the square root of both sides, you get r equals 5. The radius is 5. It's going to be a positive 5. So that's the radius. And then the volume, don't forget, is simply 4/3 pi times whatever your radius is that week cubed, which for us turns out to be 500 pi over 3 is the volume of this sphere that is being discussed. So we know the radius is 5, and that's what it came up with for the surface area. Okay, same thing for this one. It says find the surface area of a sphere with volume 288 pi. So you do the volume formula, 5 pi r cubed equals 288 pi. Pi's cancel. You're going to multiply this side times 3/4. So when you multiply it, you get r cubed equals, well, 3/4 of 288 turns out to be 216. When you take the square root, you get r equals 6. And so the radius is 6. You need to find the surface area. Surface area is always 4 times pi times 6 squared, which equals 144 pi. So that's some examples of how to use the formulas for sphere, for volume and surface area. We'll do some more examples in another video that are a little bit more complicated.